All right, hello everyone. I'm going to show you how to do some basic linear regression analysis through Excel and how to create plots. So the example I have is a Newton's Law lab where I have two objects of M1 and M2 masses in kilograms, and I'm just moving those masses in between 2 and 6 meters apart, and the simulation gives me the force. So that's what I'm starting with, and the first thing I'm going to do is draw a force versus R graph. Now, just real quick, the goal behind this lab is to try to experimentally determine the gravitational constant, 6.67 times 10 to the negative 11. And we're doing that based off of Newton's law of universal gravitation, GMM over R squared. All right, so the first thing I'm doing is, again, I'm creating that graph of F versus R. To do that, it's really simple. I'm just going to highlight over the table I want to create the graph in, go to Insert, and then click down on the scatter, and you want to hit the scatter plot. If you hover over it, it'll give you a little overview of what it'll look like. Click it, and then the plot will auto-populate. Notice the title of the plot, it just defaults to whatever your dependent axis was. And then here you can see the nice little 1 over r squared relationship that Newton's force gives us. So a couple of things I want to change on this. All charts should have axes titles. You do not want data labels. You do not want error bars. You don't want a legend because I'm not plotting more than one type of data. And you don't want a linear trend line because it's not a line. So we want just this. This is my force axis. So I'm going to say force and put my unit in brackets here in newtons. I'm going to do the same thing to my x-axis. This is my R measured in meters. And I'm going to put a descriptive title. So this is Newton's law of gravitation relationship. Okay, so there we go. Now the only thing I want to do now is notice the left-hand side of my graph has a bunch of empty space. So I'm going to adjust this axis by double-clicking that horizontal bar, and then you'll get axis options under this format axis tab. I want to change my minimum bound to 1. Now you can leave it at 0. It's not that big of a deal. I'm going to switch it to 1 just so it fits the graph a little bit nicer. It's kind of optional. The main important thing is you want your data to fit your graph well. Well is kind of a general term, but you don't want to have all your data bunched into one section of the graph. Again, in this case, it wasn't really bunched towards one section. It just wasn't looking very symmetrical. So this part is rather optional. But this is a nice graph I have of that 1 over r squared relationship. Now let's try to figure out G through using the graph. To do that, we're going to use a best fit line, and we're only going to use best fit lines on straight graphs. So instead of graphing r, I need to graph 1 over r squared as my horizontal axis. So my next step is to create a graph of 1 over r squared. So I'm going to create my table heading 1 over r squared. The units of that is going to be 1 over meter squared, or meters to the negative second power. And now let's figure out what those values are. To start formulas, I'm going to put an equal sign. My first value is going to be 1 over 2 squared, or 1 over 4, which is 0.25. So I have equals 1 over, and then r. I'm going to click the value I want. Notice it auto-populates to be A5. That's the cell highlighted in blue. And I want to square that value to get the 1 over r squared relationship. When you hit enter, I'll get that 0.25 that I was looking for. If you go to the bottom right-hand corner of that cell, double-click, it'll auto-populate and calculate all of the 1 over r squareds for the data next beside it. So if I click on this cell, for example, you can see it pulls through A6. Click on this cell, pulls through A7. So the formula knows the pattern I was trying to identify. Here's my 1 over r squared. Okay, so let's plot that. In this case, I'm going to go to Insert Scatter, and I'm going to just pull up a blank scatter plot to kind of show you an alternate way of doing this, because now I don't have my x data next to my y data. I have my y data next to my x data. So I can't highlight and then hit scatter and it auto-populates in this way. So what I'm going to do is right-click and then go to Select Data. Now, everything you graph, every y thing you graph is called a series. So 1 over r squared is going to be a series that I'm trying to graph on my y-axis. So under series, I'm going to go to add. The series name is force. Series x values is going to be all of this fun stuff. Series Y values, I'm going to delete that. Series Y values is going to be all this fun stuff. And you hit OK, and then hit OK again. And then there you go. There's my graph. My graph looks like a line, which is beautiful. I, again, just want to add those chart elements that I so deeply care about. This is still force, still measured in newtons. This is 1 over r squared, 1 over r squared, measured in meters to the negative second. And I want a descriptive title. So this is a linear relationship of Newton's law of universal gravitation. All right. Now, since it's a line, I am going to best fit this. So I'm going to hit trend line, and then you'll have that best fit that pops up. In your trend line options, we can go to more options, and then we can go to trend line options. I guess we can just go to that. So we want to display equation on chart, display r squared. You can leave everything else the same. We're only going to be dealing with linear fits in this class. So notice I have my nice little slope, and then I have my y-intercept that's extraordinarily small y-intercept. But that is a great graph. All right. Now you can extract what our experimental value for g is through that slope, because that slope should be equal to m1 times m2 times g. But what I'm going to do instead is adjust my axes so that the slope of the line is just g. What that means is in the formula, I want to plot f over m1, m2 on the y-axis, and on the x-axis, graph 1 over r squared, and that will leave me with just the slope of the line being g. So this is f. I want that to be f divided by m1 times m2. So I'm actually going to go ahead and copy this data. I'm going to go to copy and paste that here. And I'm going to adjust this. So we want to do force divided by m1, m2. Now we're in kind of an awkward unit of meter divided by kilogram squared. You can just leave it like that. If you want to expand our column, we can just double click on the column header. And now this is what I want to change. So again, I have a formula that I want to use. I'm going to do equals. I want to do my force value divided by the multiplication of my masses, which is this value multiplied by this value. Now I want to show you something. If I close parentheses and you hit enter, I'll have that auto-populate, which is great. If I click down, I have these errors. What's happening is that when your formula continues, instead of keeping at B1 and B2, it's going down to B2 and B3. So we want B1 and B2 to stay. Those are called absolute references. To make a reference absolute, we need to put little dollar signs around our letter. And in that way, the only thing that's going to change in my formula is A. It's going to go A12, A13, A14, A15, A16, and B1 and B2s are always going to stay the same. When I hit enter, I'll get the value again. Click down. Now it looks good. And this is good. So now I have my bottom graph changed. If you look at the slope, I have 7 times 10 to the negative 11. Uppercase E, by the way, is just times 10 to the. So 7 times 10 to the negative 11. Just real quick, if you put in Excel like 6 times 10 to the negative 7 or whatever, it's not going to recognize it as a number just because it doesn't recognize the notation of times 10 to the caret. So just be aware of that Excel's notation for scientific, entering in scientific numbers is using uppercase E. Anyways, so the answer that I have through the experimental slope is 7 times 10 to the negative 11th power, which is great. It 6.67 rounds to that. I can get a little bit more exact with that, though, by using an equals slope function. Slope is rise over run, which is my y values over my x values. It even tells you here I need to do my y values over my x values. So if I highlight my y values, notice I have a nice little colon that represents I'm pulling values from B5 through B9, comma, because that's what it says and how to do this formula, comma, known x's. My known x's are these. If I hit enter, I'll get that value, which is identically 6.67 with a bit of a rounding error. Also, why sig figs are important, right? Because I have 3 sig figs in my force. R was also the 3 sig figs. So I only should be recording 3 sig figs 6.67. I would not be recording 6.66814. That's how you do this. You're going to have this pattern that follows you throughout the entirety of this graph. Okay, that's all I wanted to say. Hope this helped. If you have any questions, please feel free to reach out.